When you give an image to a large language model and ask something like, explain this image, the answer is usually very short and not very detailed. This is not because the model cannot understand images. The real reason is that these models were not trained for image-based instruction following. For text, we have huge datasets where the input is a question and the output is a detailed response. But for images, that kind of data barely exists. We do not have a large-scale dataset with images, instructions, and high-quality answers. And even for humans, this is hard. If I show you an image and say, explain it, what is a good explanation? Do you describe objects, relationships, actions, or do you reason about the scene? This ambiguity makes annotation expensive and unclear. So researchers proposed a clever solution. Large language models are excellent at following text-only instructions. So instead of asking humans to directly write image-based instructions, the idea is to convert images into text first. This can be done using captions, object labels, bounding boxes, and spatial information. Once the image is represented in text form, we can ask very rich questions. Describe the image, explain what is happening, reason about object relationships, even answer logical or analytical questions. This becomes a two-stage process. First, generate structured text descriptions from images. Second, use that text to automatically generate multiple question-answer pairs per image. This creates a large multimodal instruction following dataset without relying heavily on human annotation. Now, how is the model trained? The image is passed through a vision encoder like clip to produce an image embedding. This embedding is then projected using a shallow network W into the same embedding space as the language model. The instruction or question is tokenized normally. Both the projected image embedding and the text tokens are fed into the language model together. So the model sees the image and the instruction at the same time and learns how to generate meaningful responses. Because each image has many different questions, the model learns not just to describe images, but to follow instructions, reason, and handle complex visual scenarios. This is how we turn a standard language model into a powerful multimodal instruction following system.